Welcome back to the channel. So today we are going to discuss interview question on generator. So generator is one of the advanced topic of Python. So in our future videos, we will be covering the advanced topics of Python and we'll cover the interview questions of them, right? So let's discuss about generator. So here today I'm like covering almost 10 interview questions and with this like you can answer most of the interview question of generator, right? So first of all, let's understand what the generator is. So a generator is a special type of iterator in Python that allow you to iterate over a sequence of values without storing the entire sequence in memory. Okay. So here the important things which needs to be noted, which should be noted are iterator. So it is nothing but an iterator, right? How we have the other iterators in Python, and it basically doesn't store the sequence or basically the data in memory. Entire data it doesn't store, right? So like so that's why it become really important for an like data guy, right? Someone who is working in a data field, like machine learning engineer or data engineer. So learning about the generator is really important for them. So generator use a yield keyword to produce value one at a time. So as we like learned over here that it doesn't like store everything in a memory, right? So like whenever we ask for a value, it gives the value. So these things will be clear when like we will go through the example, right? So here we can see that making them a memory efficient. So since it doesn't store everything in a memory, so it become a really very efficient for the large file when we have to process very large file and our memory size is not very huge. Like we cannot accommodate all the file data in a memory. In those scenario, like we can use generator. Okay, so let's understand with these examples. So this is how you can get the interview question. Like interviewer ask you what is generator. So you can like give this definition and you can implement the generator like this. So this is the simple generator. We will cover the some advanced generator, right? So this is how we create. So creating a generator is quite easy. We write a simple Python function, and instead of using a return keyword, here we use a yield keyword, right? In the definition itself, you saw that in order to return a value, we use a yield keyword, right? So here, if you see, we have used multiple yield. So this is also one of the interview question that can we use multiple yield keyword in a generator? Yes, we can, right? So by looking at this, you might be clear that a function with a yield keyword is nothing but a generator, right? Got it? So this is not the only way to create the generator. We can use the generator expression also that we will cover later point of time, right? Okay. So here we have the generator. Okay, let me execute this. Okay. So in a like the way we call a function, same way we call a generator also. So here we are calling a generator. It is creating an object, right? So let me call this and let me print this what the DZ is basically over here. So if you see, DZ is nothing but the generator object, right? So using this object, we can get all these values. So in order to get a value, we have to use the next keyword. So generator, to get a value, it uses a next keyword, right? So let me run this. Okay, so I ran this, I got YouTube because the first yield was on YouTube, right? And if I call this value again, like the next time, it will give Python. Why? Because what it does is basically with the help of next keyword, it basically remembers what is the state of the like state, right? And what needs to be written next. So if I run this again, it will return Python, and if I run this again, it will return tutorial. Now we have covered all these three. Now let's try to run it again. So if we run this, it we can see we are getting error because it is a stop iteration, because next when we run this time it must have ended, and it must have like written that we don't have any value after this to return, right? So we got error. I think you understood how the basic generator we can create and how we can achieve the value from it. Okay, now let's understand this. What is the yield keyword in Python? Okay, so in Python, the yield keyword in Python is used in a function to return it to turn it into the generator. This we covered. When a function contains a yield statement, it allows the function to produce a series of value over time instead of computing all the values at once and returning them. I think you understood this point. So basically, we are like with the help of yield keyword, it is not returning everything at once, right? Whenever we are asking for a value, it returning that particular value, right, in a sequence. So when a function uses yield, it does not return a single value and exit. Instead, it pauses its execution, saving its state each time a generator is called. Like we can call via these two methods using a next keyword and using a loop. So loop like internally itself uses the next, but altogether we use the next keyword, right? It resumes the execution from the last yield statement. Okay, I think the definition or the statement which we are reading over here, I demonstrated everything with practical, right? So basically, like it gives a sequence of value one by one, and it remembers the state basically, right? So this is how the yield keyword works. Okay, now let's consider the next question. What is the difference between the yield and return? I think this also I covered. So yield allow a function to pause its execution, right? It pauses the execution and return a value, maintaining its state for the next call, right? I think everything you understood now. And in contrast, return sends a value back to the caller and exit the function permanently. Like we know, right? Whenever we create a function, and if we use a return keyword, it basically ends the execution, right? So let's say if we have the function like def fun, and here we let's say print det with Dharya, and we write return. So basically it like ends the execution, right? So let's say we call a function, and see, the execution stopped, right? There is nothing after that. So return basically stop the execution permanently. Okay. Now let's go through the next question. How do you iterate through a generator? Okay. So as I mentioned, like we have two methods. One is like, okay, in order to iterate, we use a loop basically, a for loop, while loop, whichever loop we want, we can use, right? And internally it uses a next keyword in order to get the value, right? So let's take an example. So here I have created the demo generator function, and here we are iterating through the range of value, that is 10 value, and it is giving. So basically we are calling a generator, and so this value is nothing but an object over here now, right? And every time we are printing this I, right? So we are getting the value 10 value. Let's say if we want a 12 value, then we can use over here 13. So it will give 12 value basically, right? Oh, okay, altogether 13 value basically. 0 to 13, right? Let's say if we want a 50, then we can write 50 and we will get all the values. Got it? Okay. Now, let's discuss this. A generator. What is generator expression? A generator expression is a concise way to create a generator using a syntax similar to the list comprehension. Okay, so this is how we create a list comprehension, right? So in the same way, we can create a generator, but the only difference is here we use a like tuple like syntax. So here we have a tuple basically. So this is a also kind of generator without using a yield keyword or something like that, right? So this is how we can achieve this. So let's run this, and it is basically iterating through each and every element and giving the square of basically the multiplication of two of it, right? Okay. Now the next question is, can you explain the concept of lazy evaluation? Okay, so I think you understood now. Like yield keyword, some like in turn work like a lazy evaluation, right? Whenever we call, it gives the value. Otherwise, it doesn't give the value, right? So that is what over here is. A generator expression. Okay, this one. A lazy evaluation means that the value are computed only when they are needed rather than all at once, right? You understood, right? So this is similar to the what we have in Spark, basically the lazy evaluation of Spark. Like whenever we call an action to a transformation, then only it returns a value. Otherwise, it doesn't compute anything, right? In the same way, we have the yield keyword. A generator uses a lazy evaluation to produce values at a time, which can lead to the better performance and reduce memory storage. Okay, yeah, this is the obvious thing. Like since we are not doing anything in a memory, so obviously it will reduce the like memory consumption, and the performance would be better in terms of memory, right? Okay, so this is the one of the very famous problem, and even I have faced such kind of problem in interviews. So what we are doing is since it is a memory efficient method to retrieve or to process the data. So as a data engineer, we in a day-to-day life we tackle like a large huge amount of data, right? So in that case we can use basically generator in order to process the data line by line, since it doesn't store everything in a memory, right? It reads through it, and it does the job, and one by one, right? So this is how we can create. So if you see there, we have created a generator named a read file. Here we are passing the file path, and basically we are reading that file in the read mode, and we are iterating each and every line, and we are returning that particular line, right? So here if you see, we are reading each and every line over here by calling the generator, right? So let me show you the example. So here if you see in the file we have 4 lines. Let's have the other line also. Let's say we write a generator over here, generator. Next line, right? Okay, generator. Okay, and let's say here we write thank you. Okay, so and let's read this. Okay, let's save this, and let's run this. Okay, now if you see, we have read everything one by one, line by line, right? So this is how the generator helps. Let's say if you have like 10 billions of record. So instead of loading everything in a memory, like if you use a normal this only this piece basically, right? And instead of yield keyword, if you use basically a return line, something like this, a return line, and right, so it will basically everything will be there in the memory. And let's say if your memory is not that much which can occupy the entire data, it will throw an error out of memory issue, right? So in that case, this generator become really important for us, right? Okay, I think you understood this piece, and this is like one of the very important interview question. Okay, so let's move to the next question. Okay, and this is also one of the very important, how we can create a infinite generator, or how we can print infinite number, right? So using a generator, this can be achieved. So basically what we can do in order to make the loop infinite, we can use the while true, right, in a loop. And so this is one of the example where we are basically printing the infinite Fibonacci number, right? So we know what exactly the Fibonacci number is. So here we are creating the function of it. So here if you see Fibonacci, this is the function. We are initializing a and b with 0 and 1, and we are writing while true. Basically we want the infinite numbers. And we are yielding a, and we are updating the value of a and b, and we know that after like yield basically remembers its states, so it will give the proper answer to us. So here we are calling the generator, and okay, so let's go one by one, and let me demonstrate the infinite, how the infinite loop this is happening. Okay, so let me uncomment this first. So what we are doing over here is we are calling this generator function, right? Here we have x. So x will be nothing but what? First time it will be a 0, and then again, like in the next iteration, it will be 0 plus 1, 1, right? In the next iteration, again, it will update. So since we are using the while true, it will keep on happening and it will not break, right? Let me run this. So if you see this, it it gave the like infinite value, and program exited because there were like the memory full, get full, right? So this you can demonstrate in an interview, right? So let's break this code. So basically this is the okay. Now let's generate only the first 10, basically the Fibonacci number, right? Okay. So what we are going doing is we are generating this like, and we are saying just give 10 values, right? And we are using the next to get the values, right? So we can run this. So if you see, we got first 10 Fibonacci number, right? And this is the other way to get it. And similarly using like this also, without using the next keyword also, we can get this. So we are saying we need 10, and using like we are using I over here, right? And we are using count to maintain the number of record which we need, and we can run this. So this will also give 10 basically, right? This is giving basically the next 10 values of it, right? So I think you understood how the generator is working, and let's learn about the next interview question, why to use generator basically. So here are a few pointers which I have listed down, which are very important. Generator yield item one at a time, makes them ideal for the large data processing. Understood? Reading the large file line by line is one of the example of it, right? And we can generate the infinite sequence out of it. So generator allow you to define the infinite sequence as they produce value on the fly. Example, sequence of Fibonacci number. So yes, I think you understood this. So like we will in the next interview, like in our we might cover the multi-threading or decorators in Python. So all these kind of question we will cover in our next videos, right? So yes, if you like this content, please do like, subscribe, and share the channel. Let's meet in the next problem.